stops sharing. So, welcome to the first live of the class. We're in week 2, and so this week I'm going to go over multiplying polynomials because that's going to be something they're going to be doing a lot throughout the term, and so that's a good thing to start off with. So these are recorded, so if you end up having technical difficulties or you can't make it for whatever reason, I will email them out the next day and you'll have the recording and it's posted on YouTube. I know I had to reschedule today. Today is because I had to pick up my dog from the vet, but normally I don't need to reschedule them. This is a kind of unusual situation, of course. These things happen. So you don't have to have your camera on. You don't have to have your microphone on. It's up to you what you feel comfortable with. There's a chat feature, so if you feel comfortable with the chat feature, that's fine. You can use that. I usually try to make these somewhat interactive if we have a large group because, you know, then it's more like a class. But if with a small group, then I feel like I'm just kind of forcing you to participate. So, oh, I should put my phone on mute. My baseball team, the Cubs, are ahead. Woohoo! Anyway, so I'm going to start by sharing my screen, and then I will go through the lesson. You are welcome to stop me at any time and ask questions, so you can raise your hand. There's a little button on the bottom that you can click to raise your hand, or you can just type your question into the chat. And that's basically how this goes. And the PowerPoint that I use, that I write all my notes on and everything, I do share that out the next day. So if you know, some people like to take notes at the same time. Some people prefer to watch and soak it up and then copy down the notes later, whatever method works for you. So we're multiplying polynomials, and so it's important to kind of know what is a polynomial so you know what you're dealing with here. So a polynomial is where we basically have a sum of things together. A polynomial will have variables in it, usually x, and they have exponents on them. And so the basic form is ax to the n. The a is just a number that's in front. So, and then you have a variable, and then you have an exponent, and then you just have a whole bunch of these added together. So a common type of polynomial is a quadratic, which is usually in the form of ax squared plus bx plus c. We just use a, b, and c as constants, but that could be something like 2x squared plus 5x minus 10. So that's a polynomial. You're just got a series of things that are added or subtracted. They've got variables, they've got exponents on the variables. The key thing is that if you have any fractions, no variables are in the bottom, because if there is, that's named something else. If you have square roots or absolute values, there's no variables inside those because those have different names. And there are no negative exponents and no exponents that are fractions. So all the exponents are whole numbers, and that's what makes something a polynomial. It's important to be able to recognize if something is a polynomial because there are certain things you do to polynomials that you don't do to other things. So part of algebra, I hear a lot of people say, I get so confused, I don't know what to do when. And a lot of that comes back to, well, what do I have in front of me? If you have a polynomial in front of you, this is a list of things that you can do. And then you go and say, okay, if it's asking me to do this, then this is the procedure. So you have to be able to recognize what you have in front of you, and because it's in a certain category, and then you go into that category and you look at the list of things you can do. So we'll have polynomials, we'll have rational functions, we have absolute value equations, we have radical equations. These are all separate categories with a separate set of rules for dealing with each one. So knowing the definitions are really important. Knowing the terminology is really important because that helps you categorize everything. So, terminology of polynomials. So, basically this is just very mathy speak of just showing each term. So in this the math speak here, we're just counting down. So if this was like, if n was equal to 2, then we're just counting down the exponents. And this is just a way to count. So you start at 0, 1, 2, 3, and 4 just as an index, these subscripts. And then they just kind of correspond with the variable on top. The math that you see here that I've circled and underlined, that's not so important for you to know, because you don't really have to know like the specific definition and that kind of stuff. You're going to just want to be able to, if I see this thing in real life, what does it look like? You know, with numbers. That's what's important for you guys to know. So if there's one term we call it a monomial. So going back to the word polynomial, poly means many. And then nomial comes from the Latin word nomen, which is name, or in this case, like terms of things. Like if you like term is used as a word, you can say use name as a word. So it's just like many things. That's like what the word literally means, is you've got many things. So if you look at these words, monomial, binomial, monomial, binomial, trinomial. Mono means one. If you think of like a monocle, has one, it's just one, it's half of glasses, it's just got the one glass. There's you've probably heard of the sickness mono. It stands for mononucleosis. It just means one nucleus or whatever thing. Binomial, that has two terms because the word bi means two. Think of bifocals as two lenses in it. And then we've got a trinomial. Tri is three, like a tricycle. So these words that we have are just literally naming themselves. They're just using like Greek and Latin words. Ah, you found out the chat. Yay. First time in this thing is always a little tricky. So I get it, especially if you happen to be on your phone. All the stuff is like looks different. So all of our math terms come from like Latin and Greek a lot of the time, because that's what a lot of science and math and all that was done way back when, and then we just kind of carried that forward. So we've got these words monomial, binomial, and trinomial, and they're special names for one term, two terms, three terms. And then anything higher than three terms, we don't have a special name. We just call it a polynomial. We have special names for a monomial, binomial, and trinomial because those are the ones you see the most often. And so if you deal with them a lot, you want to give them a special name. So some examples of a monomial, like if you just see a number by itself, in algebra, a number by itself would be called a constant, but it is also a monomial because it's one term. You can also have a monomial that's a number and a letter, but there's nothing added or subtracted. It's just one term. So 2x is also a monomial. A binomial is when you combine things with pluses and minuses, so you have two things together. So we could have 2x plus 5. That is a binomial because you've got two things and they're separated by a plus sign. And then a trinomial is three things and they're separated by a plus or minus. So that could be like x squared minus 7x plus 4. So you've got two things, and if you don't count the plus or minus, you can highlight them. You can see, okay, I said two things, three things. Hence it's a trinomial. And binomial has two things, and they've got like a plus or minus in there. So a lot of times when we're talking about multiplying, you'll see like multiplying binomials. And so knowing what a binomial is important, because if you're told to multiply binomials, you need to know what you're looking at. So that's the terminology here. If I can get my slide to move forward. All right, so let's move on to multiplying these things. There are multiple ways to multiply. So there are essentially four different methods. And our textbook does not teach every single one of these methods. So we've got a vertical method, and the vertical method is very similar to how you multiply by hand. So like to show the vertical method, like if you were going to do 32 times 12, you know, if you're multiplying these by hand, you would first do 2 times 2, which is 4, and then you take that the lower 2 times 3 is 6, and then you move on to the 1 from the 12. 1 times 2 is 2, 1 times 3 is 3, and then you add these together. That is the vertical method. And you can do that even when you involve variables. So you can multiply these things vertically. I personally don't like this method once you have variables. So I am not going to teach this method because it's very confusing. You can find it in the textbook, but I don't think it's too confusing. I don't think it's very intuitive. So I don't use that method, but it's there. The other method that we have on the list is the distributive property, and this is usually used if you have a monomial times anything else. So you have one thing in front of parentheses, and you saw that with the order of operations when you would use the distributive property. So you can use the distributive property when you have 2 things multiplied together or 3 things or whatever, but it's a lot harder. So I recommend only doing it when you have one thing multiplied by a bunch of things. But I will show how you can do it in other ways as well, just in case, because you know that may be your preferred method. And the reason why I'm going to show multiple methods is because, you know, everybody thinks differently, and you want to find the method that works for you, because what method works for you may not work for someone else. And I know way back, you know, when people usually learn math, they're told this is the way you do it, and you always do it this way. But that's not really how it is. We have lots of different ways to do things. Some are better than others in certain situations. Some work better for your brain to make sense than other things. And so by learning multiple methods, you get to choose the one that makes sense to you so you can be more successful. So I like to teach multiple methods, and then you can choose what works for you. I use many methods depending on the situation, and that's totally fine. Or maybe you just choose one and you're like, I'm always going to do it this way. That's completely fine. So it's vertical, distributive property, the table method. So that method is not shown in the textbook, but the table method is very similar to when we have our multiplication tables. So, you know, when you were growing up and you'd have all the numbers going across horizontally and then the numbers vertically, and then you multiply them together like in a grid, you know, like 1, 2, 3, 1, 2, 3. And so you'd have 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, and then next row 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. 3, 6, 9. So like way back, way long time ago in elementary school, when you're learning multiplication, you have multiplication tables. That's the table method, and you can use that for variables, and it works really nicely. So we're definitely going to cover that method. And then the last one is FOIL, and that's only when you're multiplying binomials. So this is a special case that cannot be used all the time. So you have 2 things times 2 things together. And that's the only time you can use the FOIL method. So we will show that, but it doesn't work every time. So that's another thing that it's like, okay, this is a great skill, but you need something that also works when you don't have that situation. So I'm going to cover 3 of these. I'm not going to cover the vertical, but I'm going to do the distributive property, the table method, and then FOIL. So we will start with the distributive property. And so I've got 2 examples here. And the first example is the situation where I recommend you use the distributive property. The situation on the right, you can use the distributive property, but I don't think it's the best option. But you can use it. So basically, that situation on the left is we have something times something plus something, or you can have lots of things inside. So I'll just do dot, dot, dot. But you have one thing in front, and then you're multiplying by things in a parentheses. And you've got pluses and minuses or whatever. That's the best use for the distributive property. So first off, when you're multiplying, so it's always good. I like to write down the steps, and this is good when you're taking notes, to write down the steps so that you have your procedure to follow. And if you get into good habits when you're writing your math, it'll make everything else easier. So you need to take good notes. You need to write down the directions. You need to write down the steps. You need to be able to see what the steps are and the pattern is. Because math is a lot of patterns and it's a lot of rules. And so you need to be able to see those and then apply them in different situations. So I always recommend for anyone first learning algebra or hasn't done it in a long time to turn every subtraction into adding a negative. So we're going to rewrite subtraction as adding a negative. And the reason why I recommend doing this is because the most common mistake people make is getting their signs wrong and messing up something when negatives are involved. You are less likely to make these mistakes if you rewrite subtraction as adding a negative. So that's you. It's everybody. Even I still make sign errors and mess it up. So if you get in the habit of rewriting subtraction as adding a negative, because those are actually the same thing, you're less likely to make those sign errors. So what that means is that we're going to still have our negative 2x cubed in front, but in parentheses, I'm going to have 15 plus negative 5x squared. So step 2 is where we actually distribute. And what that means, because you need to know, if you see the word distribute, what does the word distribute means? Multiply the inside by the outside. So I like to use arrows to kind of help me keep track of this. So you're multiplying your negative 2x cubed times 15. And so you can just literally write that so that you can double check that, okay, I'm doing that. And then you put a plus, and then we're going to be multiplying the negative 2x cubed by the negative 5x squared. And so I usually do this multiplication in my head. I don't write down what I just wrote down. But at first I thought I made a mistake. Nope, that's right. But I recommend you write down this step when you're learning. You know, you don't want to skip steps too early. The book will show you this step in the beginning, and then they'll skip this step for future problems. Even if you're looking at an example in the book or another video, if there are steps that are skipped, in your notes, you can pause or, you know, write in those missing steps to help you if you're not ready to skip those steps yet. I don't recommend skipping steps until you're confident. And so this would be one where I'd first write down exactly what you're doing so that you can see what's going on. Color coding also helps too, if you like to color code. And I'll show an example of how to do that as well. Step 3 is simplify. And now the word simplify means we're following the order of operations. So it basically means you do if you have things going on inside parentheses, if you have any exponents, anything you need to square, any multiplication, division, all that kind of stuff, and then you add things together. So simplify means follow the order of operations. What that means in terms of this problem is that you multiply your numbers together in each term, and then with the exponents on the variables, you add the exponents, because that's how we multiply these things. So we have negative 2x cubed times 15. So I have negative 2 times 15, which is negative 30. And then it's just x cubed because I don't have any other variable that I have to worry about. And then on the right here, I have negative 2 times negative 5, so that's a positive 10. And then I have an x cubed times x squared. So when you're multiplying things with variables, you add the exponents. So that gives us x to the 5th. And then you would see, can I add these two things together? You can only add these together if they have the same numbers on the exponents and the same letters. They've got the same variables, they're both got x, but the exponents are different numbers, so we cannot add those. So this is your final answer. So taking notes is a lot more, takes up more space than the actual math that you're doing. Like the notes is the stuff in white, the math is the other stuff. And it's really only 3 lines, but when you're taking notes, you need to write so much more than just the math. You need to write down the directions so that way you can use your notes later on when you're looking at a problem. Are there any questions on this one? Okay. So that is the example on the left. And always do your math vertically, because when you're solving, we always work, we're doing things on both sides and then we're working underneath it. So all math is done vertically. So make sure that's in your notes as well. You've got to have good practices now, because if you get messy note taking in the beginning, when you get into the more complicated stuff, you're going to get lost. So it's good to start good habits from the very beginning. So the example on the right, we're going to be following the same process here. So the first step is to rewrite any subtractions as adding a negative. And anything like the negative x there, I'm going to just add a 1 there so that you actually have a number that you see. So negative x is the same as negative 1x, and sometimes it helps to actually see that number instead of just knowing that's assumed. So I just had to change that negative x to a negative 1x, and then minus 6 to adding a negative 6, and then the other part can stay the same. We don't have to, there's no subtractions in the second part. So how the distributive property works in this situation is that your first term gets multiplied by everything, this whole thing. So we would have negative 1x times negative 2x to the 4th plus 13. And then the negative 6 gets multiplied by that whole thing. So it'd be negative 6 times negative 2x to the 4th plus 13. If you had more things, like in front, if there were 3 things in front, then you'd be multiplying 3 things by the second set of parentheses. So then we have to actually do the distributive property a second time, because we have basically the example that we saw on the left. You have 1 thing times 2 things. So you essentially have to do the distributive property multiple times. So we get negative 1x times negative 2x to the 4th plus negative 1x times 13 And then I have my -6 plus -6 times -2x to the fourth. And then -6 times 13. And if you're running out of room, like I am, I have a lot less room than you would have on a piece of paper. You can just kind of write it underneath like that. And that's also why I'm changing colors here, so you can see by color each new line. So once you've divvied it up, so you've got one thing times one thing, then you can start the simplify process where you start actually multiplying these. So we have a -1x times -2x to the fourth. -1 times -2 is a +2. X has an exponent of 1, so when you add those exponents, you get x to the fifth. So sometimes it helps to actually write that exponent there. Then -1x times 13. So -1 times 13 is -13, and then I have x. Then plus -6 times -2x to the fourth. So -2 times -6, that's 12x to the fourth. And then I have a -6 times 13, which that one I need my calculator for. I cannot do that one mentally. 78, so that's a -78. So then you look to see if there's any like terms that you can add together. They have to have the same variable and the same exponent. So we don't have any like terms here. But what we do is usually we write it from the highest exponent to the lowest exponent. So we might rewrite this as 2x to the fifth plus 12x to the fourth minus 13x minus 78 as your final answer. And that is what we call standard form. So we've got two examples here, the distributive property. The example on the left is the situation where I recommend you use the distributive property. The example on the right, I do not recommend using the distributive property, but you can. It kind of gets kind of messy. Any questions? Okay. So I've just demonstrated that the one on the right, you probably don't want to do the distributive property because it can kind of get confusing because you have to do it multiple times. So what should you do? You know, what's a better way to do it? That's the table. So if you have something like 2 things times 2 things like we see here on the right, that's where I would use the table. Or you can use FOIL in that situation as well. Why did 13x not get added to the 12x to the fourth? It's because the 13x, the x has has no exponent on it at all, and the 12x to the fourth has an exponent of 4. So they have to match. So since one has no exponent, the other one does, they can't be added together. They're not considered like terms. You can kind of think about it as units, like a 13x would be like 13 inches, and then like 12x to the fourth would be 12 inches to the fourth. Doesn't really make sense in the fourth, but if it was like squared, it would be inches squared. You can't really add a linear dimension like length to an area, which would be inches squared. So that's why those are not like terms. Now, second question about the 1x with the exponent, the one that I wrote in there. Anytime you see a variable and there's no exponent, you can always put a 1 on it. And this is because you literally have a single x. You're not multiplying it by anything. It's just multiplied 1 time just by itself. So I put the 1 in there in that case so that you could see that I'm adding the 1 and the 4 together to get to an exponent of 5. because sometimes if you don't put that 1 on that exponent, people forget to add those together, and then they have the wrong exponent in the next step. So if you write in the 1 in that case, when you're starting to do your multiplication, that can remind you, I need to add those exponents together to get to a 5. Are there other questions, or did that answer your questions? Did that help? Yeah, so 13x with no exponent, that's correct. You could put an exponent of 1 on the 13x. We generally don't put exponents unless we need them for something else, and then we will remove the exponent or don't put it if we don't, if it's not needed. So because the 13x is not, we're not adding it to anything else, we're not subtracting it or anything, multiplying or whatever, we don't need that exponent there. Okay, so connection problems. On my side, it's showing all 3 of you guys are having excellent experience. That's what it says on my side. So if it's lagging, you might want to try refreshing the page. It looks like Charnel did lose the connection temporarily. So, and now is back. So you might want to try refreshing and see if that works. If nothing else, the recording shouldn't have any lag, so the recording should be the same. Are there any other questions? Okay, I'm gonna move on. Okay, so multiplying using a table, which I definitely, if you have these 2 different problems, 2 things times 2 things and 2 things times 3 things, I would definitely use this method for the thing on the right, where you're multiplying more than 2 things together, because on the left you can use FOIL, but on the right you can't. And so I would definitely say you would want to use the table method in that situation. So here's how the table method works. So our step 1, just like before, you want to rewrite all negatives as, or all subtractions as adding a negative. So that's just a good first step, no matter what you're doing. So this will give us 3x to the 5th plus 5. And I'm going to also put a 1 in front of the x to the 5th so we have a number. And then plus a negative 9. And then step 2 is to make a table and multiply. And we multiply row times column. So it doesn't matter which is going across or which is going down. I usually just go across to the first one. So 3x to the 5th, you don't need to write the plus sign. You just need to write the terms themselves. And then going down, I have negative 1x to the 5th. And then another row, I'd have the negative 9. And so this essentially gives me 4 boxes that I'm filling in. And I like this because you've got 2 things that you're multiplying by 2 things, and so you should get 4 things after you multiply those together. And this helps you keep track to make sure you haven't forgotten anything. So we fill in the table row by column. So I start with the negative 1x to the fifth, and I multiply it by 3x to the fifth. And this is where I do the multiplication negative or mentally. So negative 1 times 3 is negative 3, and then you add the exponents. So 5 plus 5 is 10. So this is going to give us x to the 10. Then I move to the next box with negative 1x to the fifth times 5. So negative 1 times 5 is negative 5, and then I have x to the fifth because I don't have another x that I'm multiplying by. Then you move to the second row. So I'm multiplying negative 9 times 3x to the fifth. So negative 9 times 3 is negative 27, and then I have x to the fifth. And then moving over, I'm left with negative 9 times 5, so that is negative 45. So you filled in your box, and what I like about this method is if you set it up nicely, the diagonals are like terms. Because you can see on that diagonal, they both have x to the fifth. Now, they're not always like terms. It kind of depends on how it comes out, but most of the time they are. So if I add those together, I get negative 27x to the fifth plus negative 5x to the fifth. And that gives me a negative 32x to the fifth. And so I can just kind of write that number up there. And then my answer is coming from these boxes. So I have negative 3x to the 10 plus, and then the diagonal, which added to negative 32x to the fifth, plus, and then the last box is negative 45. And so that is your answer from the multiplication. So I like that method because it organizes things. If you filled in every box in your table, you know you've multiplied everything properly. It's easy to check your work because all you have to look is the row times the column to make sure you did your multiplication correctly. So it's really easy for checking your work. And then it's really easy for getting your answer. Are there any questions on this example that I just did? Okay. So second example, we have two things, and then we're multiplying by something with three things. So we're going to end up with 6 boxes. So you're going to have 6 terms after you do your multiplication. 2 times 3 equals 6. So first step, we're going to rewrite all of our subtractions as adding a negative and put in any ones where we need to. That might make our lives easier. So this is x to the fourth plus negative 4 times 2x to the fifth plus negative 1x to the fourth plus 1. And then we make our table. And you can do it, it's going to be a rectangle because we're not multiplying things in the same size. So you can either have 2 columns, 3 rows, or 2 rows, 3 columns, whichever way you want to do. In this case, I'm going to put the second thing on top just because it takes up a little less space, but it really doesn't matter. And then I can kind of draw my grid here. So we're going to get 6 boxes there. And now I'm going to multiply inside my grid. I should actually Right, I'm going to put a 1 in front of that x to the 4 as well, just so you can see what numbers you're multiplying together. So row times column, I always start with the first row, first column. So 1 times 2 is 2, and you add your exponents. 4 plus 5 is 9. So I get 2x to the 9. Moving to the right, 1 times negative 1 is negative 1. Add my exponents, it gives me x to the 8. Move to the right, 1x to the 4 times 1 is 1x to the 4th. Then I go with the second row. Negative 4 times 2 is negative 8, and then I have x to the 5th. Then negative 4 times negative 1 is 4, x to the 4th. And then negative 4 times 1 is negative 4. So once you fill in all the boxes, you look for like terms. So in this case, these are like terms. In this diagonal, they're both x to the 4th, but not the other diagonal before it, because the one before it would be x to the 5th and x to the 9th, or x to the 8th. Those are not like terms, so you can't add those. So I only circle the ones that I can add together. And when you add those, you get 5x to the 4th. So the way that I read my answer is I follow the highest exponent. So I'm going to do this box first, 2x to the 9th. This is the next highest, minus 1x to the 8th. Then x to the 5th. So they kind of go zigzag. So minus 8x to the 5th. Then I'm going to use the x to the 4th, because that's the next one, plus 5x to the 4th. And then the last box is negative 4. So it kind of zigzags because you're kind of following the exponents. You don't have to write it in that order. That's just our standard order that we write it, because we have the highest to the lowest as the exponent. But that's your final answer then, because I already did the adding by circling the things that were like terms and combining those together, and those were on the diagonals. Do we always add the exponents and not multiply? Yes. Whenever you multiply things that have exponents, the exponents themselves always add. So one way that I think about it is like if we've got PEMDAS. So usually we're multiplying, dividing, adding, or subtracting. So on the exponent, you multiply, it goes to addition. You divide, it goes to subtraction. Like it goes to the last two of PEMDAS. And then addition and subtraction do nothing to the exponent. So I think of like the exponent as kind of a subset of the order of operations when I'm thinking of PEMDAS. So multiply is multiplying things with exponents. The exponents add, they go 2 down, you know. Division, okay, 2 down from that is subtraction. But then when you get to addition and subtraction, there's nothing left to do, so you don't do anything to the exponents. So that's how I think about it in my head, to keep track of whether I add exponents, multiply exponents, that kind of thing. You multiply exponents when you have an exponent on top of an exponent. So that's even like the e in PEMDAS goes to the m. So the e in PEMDAS goes to the m when you're dealing with exponents. So if you have an exponent on top of that exponent, you multiply them together. Other questions? Okay, so the last method is FOIL, which stands for first outside, inside, last. And this only works if you have two things times two things. So it would work on this example on the left. I would use FOIL there. And the example on the right here, you could use FOIL. So something that you might want to do on your own is to multiply these using FOIL and see if you get the same answer. That's a really good way to practice. Is say, okay, we use this method. Let's see if I can get to the same answer using FOIL. So the way I keep track of FOIL is the first, when we talk about the first, and I'll try to color code these. So I'll make that blue. We mean the first term out of each set of parentheses. So the first thing in the first parentheses times the first thing in the second parentheses. Outside is referring to the two outside numbers there. You multiply those together. Inside is referring to the inside numbers. And then last is referring to the last thing in both terms. So the way that I draw my arrows, I call this my FOIL face because it literally looks like a smiling face. When you put in all the arrows and you do your multiplication, it looks like a face. And if you have like a minus instead of a plus, it just makes the face winking. And if they're both minuses, then the face is sleeping. So I call it my FOIL face. But some people just use the words first, outside, inside, last. I use the parentheses in the shape that I get to help me remember FOIL. So it only works when we've got these two types of problems, two things times two things. So we've got two things times two things, and you are going to get four things. So step one is always to rewrite your subtraction as adding a negative. Just good practice. And I'm also going to throw 1 in front of that x just so I have a number there. So I'm going to write that as negative 1x plus negative 2 times 7x squared plus negative 5. And then step 2 is you're literally doing FOIL. And so I'm going to color code. So the first terms I multiply together. Negative 1x times 7x squared plus. Then we're going to do the outside terms. So that's going to be negative 1x times negative 5x. Then we have the inside terms. So I'm going to just put this off to the side here. Negative 2 times 7x squared. And then your last terms. Negative 2 times negative 5. What FOIL has done is basically taken what was the distributive property and kind of skipped a few steps. So if you see what we've done here, this is very similar to what we got right here, this step. Maybe I should use a different color there. This step in the darker blue here, where we got these four things that we multiplied. So FOIL is basically skipping that step in green. It's skipping this step by doing FOIL in this particular situation. So it saves you a step. And when you start getting good with your multiplication and, you know, really getting those rules down, then you can even skip the second step and go straight to here. So FOIL is just a different way to organize what you're doing and help you keep track. Whoops, went too far ahead. There we go. Okay, so FOIL, and then step 3 is to actually simplify. So you are adding, you're multiplying, and then you're adding your like terms together. So I have a -1 times 7, so that's -7, and then you add the exponents, so that's going to be x cubed. So if it helps you, you can put a 1 above the x, so 1 plus 2 is 3. Then in purple, -1 times -5 is a +5, and then I have an x. Then yellow, -2 times 7 is -14, x squared. And then -2 times -5 is +10. And then you would look to see if you have any terms in common, anything you can combine together. We don't have anything that can combine together, so I'm going to just rewrite this from highest to lowest. 7x, -7x cubed minus 14x squared plus 5x plus 10. So this example, I've demonstrated how you could use color coding in your notes. So I did each step of FOIL in a different color, and that helps me when you're checking your work, because then you know what you multiplied together to get that color. And you can even continue with the color coding in the next step. So instead of writing the -7x cubed in the orange, I could write it in the colors that I multiplied together. So you could use color coding in a way to help you keep track of things and make it easier to check your work so you're not getting lost in all of your stuff. So, you know, not everybody does color coding. Everybody has a different method of color coding, but this is just one example of how you can use it. Some people use highlighters and will highlight the stuff and then use that as their color coding. So kind of whatever works for you. Some people don't color code at all. I just wanted to sort of demonstrate how you can use it. Are there any questions on this example? Okay, so I'm going to do the example on the right. Again, this is one where you FOIL because you do 2 things times 2 things. So I'm going to start by rewriting any subtraction as adding a negative. Actually, I'm going to move that down so I have room for my arrows. And then I'm going to start doing arrows. So first, 6x times 8. And what I usually do is do that multiplication in my head. So I'll show you what that looks like instead of writing every step. So I'd literally say, okay, 6 times 8 is 48. And then I have the x. Then outside. 6x times -2x to the 5th. So 6 times -2 is -12. And then I have an x has an exponent of 1, so 1 plus 5 is 6. So that's going to be x to the 6th. Then we have insides. 3 times 8 is 24. and then last. So that's 3 times negative 2x to the 5th. So 3 times negative 2 is negative 6, and then x to the 5th. So you can do some of that multiplication in your head to kind of not show, you know, to save some space. You don't have to show much work, but, you know, when you're first learning, I would do what I did on the left and show every single step when you're first learning. Then what you would do is just usually we'd look for things that we can add together. They have to have the same variable and the same exponents on the variable. These are all different, so I can't add them together. So we usually just put them highest to lowest. So that would be the x to the 6th part first, so negative 12x to the 6th. Then the minus 6x to the 5th. Then the thing with the x, so plus 48x, and then plus 24. And then that would be your final answer. Are there any questions? Okay, so I usually overplan, and I have like a whole bunch of like special cases for you guys for this kind of multiplication, but they're special cases, so they're not important for you to memorize or anything like that. These methods are all you basically need for the multiplication, and we do multiply a lot in this class. You're going to be doing a lot of multiplication, and we're going to be doing a lot of factoring, which is reversing the multiplication. It's basically undoing everything we did here. So hopefully you found at least one method that works for you out of all of these examples. You know, you can choose between FOIL when you've got two things by two things. You use a table. Yeah, a lot of people do like the table method. So I will do the table method. If I have anything that's bigger than a binomial, instead of a 2 times 2, if I have anything bigger than that, I will do the table method. Never heard of it. You know what? That's kind of funny because I was not taught this table method in school. You know, all this stuff about Common Core and the new math and everything. This is what they teach. I'm like, you know what? They kind of know what they're talking about. Like, this is a thing that I stole from the elementary students that I was tutoring who were in Common Core. Because I'm like, why don't we teach algebra this way? It makes so much sense. And actually, in Japan, the way that they teach multiplication, like, you know, if I go back to where we were talking about the vertical method, where is it? Where's my vertical method? So, like, in America, when we learn how to do multiplication, we do that vertical method on the left. In Japan, they use the table method. They actually do something like the table method to multiply stuff, which makes sense because then it's like, oh, that's the same thing you do with variables in algebra. And it's like, no wonder they're so good at math because they're doing the same thing. Like what they learned in elementary school matches what they do in high school. So it just makes sense. America doesn't do that. we can improve. But now you guys have this method. And yeah, the table method is fantastic. So I'm glad that you guys really like that. And you can go ahead and do that for all of these problems because it works for all of them. You can even do the table method with the distributive property. You just have one row, you know. So really nice stuff. So that's what I got for you guys. So this recording, I'm going to send it out tomorrow morning. I usually do a little bit editing if I need to, just double check, you know, that there's not like random sounds and that the sound is good and all that stuff. So it's not usually immediate in the morning, but I will email it out to, so it goes to, I will email it to everybody, their Grantham email address. I posted in the announcements, so it's always in the announcements. It's also linked in the video section of class. That's where I compile them all. And then I also include the PowerPoint so that you'll have your notes here. You'll have these notes, and then you can do what you will with them, you know, whatever you want to do with your notes. So you'll also have all the PowerPoint slides as well. So to log out of this system, you could just close the browser and it will log you out. So you don't have to do any fancy things to close. You just X out and then you leave the session. So I hope you guys found this useful. I don't know if you can hear my whining dog. I can hear her. I don't know if that's coming through in the microphone. But she's very, very unhappy after her surgery. So I'm probably going to go downstairs and spend some time with her because she was very unhappy. But you guys have a wonderful night. Next week, it will be at 6 p.m., a couple hours earlier. I know we've got people on Eastern, so this is a little late for you guys, but it will be at 6 p.m. next week unless something else happens. Yeah, poor baby. She has had like a growth on her eyelid, and it started getting bigger, and it's on the inside, so it started like pushing her eyelid away from her eye, and then it was like bleeding. So we had to get that removed, and they're hoping it's not cancer. Crossing fingers it's not cancerous or anything like that, but it was really bothering her, and it's like, yeah, this is not good. This is like interfering with her eyesight. So she's not happy with the anesthesia. She just does not take it well. So all right, well, I will stop chit-chatting with you guys. I'm gonna go spend some time with her. Hopefully she and I can both get some sleep tonight. Crossing fingers. You guys have a wonderful night. Have a wonderful Friday. You know, wonderful weekend. We've got a new holiday, Juneteenth, coming up this weekend. So, you know, I don't know if anybody's got anything planned for that, but that's brand, you know, news. So you guys take care. I'll see you at the next one.